For centuries, the Great Pyramid of Giza has forced a choice between two irreconcilable views. It is either a masterpiece of pragmatic engineering or a deliberate repository of advanced mathematics. The mainstream archaeological consensus leaves little room for hidden codes. In this view, the specific slope and towering dimensions of the pyramid were dictated strictly by the limits of ancient masonry: block size, load-bearing capacity, and structural stability. But a persistent counter-hypothesis, argued by theorists like Dan Winter and mathematician Ralph Abram, proposes something else entirely. They suggest the architecture was meticulously chosen to encode specific mathematical constants. At the center of this debate are two numbers: the golden ratio, represented by the Greek letter phi, and the circling ratio, pi. If the architects of Giza intentionally built both of these constants into a single structure, it requires a level of geometric precision that directly contradicts the accepted timeline of human mathematical discovery. The face slope closely approximates phi, or 1.618. Meanwhile, the ratio of its base perimeter to height approximates pi, at roughly 3.141. But proving the pyramid intentionally houses both creates immediate mathematical friction. Phi and pi belong to completely different mathematical species. We are going to examine the rigorous algebraic proof that permanently separates these two numbers on paper, and then explore Ralph Abraham's proposed solution to the paradox. Abraham offers what he calls Answer 3, a philosophical framework that attempts to reconcile these constants physically in three-dimensional space, rather than relying on strict numerical formulas. To understand how a physical monument might synthesize phi and pi, we first have to understand why pure mathematics strictly forbids them from ever connecting. This chart visualizes the dividing line in number theory, separating the numerical universe into two distinct categories: algebraic numbers and transcendental numbers. An algebraic number can act as the root of a polynomial equation with integer coefficients. Phi sits securely inside this boundary. Pi, however, is a transcendental number. By definition, it is mathematically impossible for pi to ever serve as the root of any such algebraic equation. To test if these two numbers can be forcefully linked, mathematicians use this specific polynomial. P of w equals w to the fourth plus 2w cubed minus 2w squared plus 2w plus 1 equals 0. This specific polynomial is irreducible. If you try to substitute relationships between phi and pi into this equation, the math immediately collapses into a contradiction. This barrier is formalized by the Gelfand-Schneider theorem, an absolute law governing the separation of algebraic and transcendental values. Because of this theorem, the formulas proposed by esoteric theorists, like claiming pi equals phi squared or pi equals phi multiplied by an integer, are mathematically impossible. This is why mainstream mathematicians dismiss alternative pyramid theories outright. Pure number theory proves that no single seamless formula can ever equate both constants. Pure linear algebra perfectly and permanently isolates phi from pi. Any theory that requires them to be mathematically equated on paper is false. But architecture does not exist on a theoretical Cartesian plane. It exists in the physical, imperfect reality of stone and gravity. This chart overlays historical data onto the pyramid, isolating the perimeter-to-height ratio roughly at 2 over pi. Mainstream analysts consider this an approximation. Within the margin of error for an ancient structure, builders likely used 22 over 7, not the true transcendental number. Esoteric theorists counter that if you calculate the original dimensions, accounting for millennia of erosion, the structure aligns perfectly with the true infinite decimal of pi. This creates a historical paradox. If the builders intentionally and perfectly embedded a transcendental number into the masonry, they possessed a working knowledge of advanced number theory long before it was formally discovered. But arguing over construction tolerances and historical measurement errors misses Ralph Abraham's larger philosophical point. Why do two distinctly different mathematical concepts appear to intersect inside this specific shape at all? To move past the debate over measurement fractions, mathematician Ralph Abraham introduces a new framework he calls sacred periodicity. Sacred periodicity is the theory of geometric recurrence. It observes that structural patterns reliably repeat across vastly different scales of the natural universe. This diagram connects the constant phi to the natural world as the mathematical limit of the Fibonacci sequence, a rule found throughout biology. Microscopic structures, like DNA rungs, inherently rely on these exact Fibonacci proportions to maintain physical stability and replicate. Abraham takes these microscopic biological realities and maps them directly back to the macroscopic dimensions of the Great Pyramid. Under this theory, the Great Pyramid operates as a macroscopic architectural blueprint, physically modeling the microscopic geometric laws that govern nature. This brings us to Abraham's Answer 3, an epistemological synthesis meant to bridge the gap between skeptical mathematicians and esoteric theorists. The absolute truth of number theory remains intact. Phi and pi are algebraically independent, and no linear equation will ever connect them. Yet, despite this mathematical independence, nature physically manifests both constants simultaneously within the very same structural spaces, like the architecture of a living cell. Abraham's resolution is that pure linear algebra is simply an insufficient language. It fails to fully describe the holistic, physical geometry of the natural world. When theorists label the pyramid sacred, it does not require mysticism. It means the structure serves as an architectural manifestation of this natural geometric overlap. The true value of the Great Pyramid is that it forces us to recognize a strict boundary condition, the point where our abstract mathematical proofs fail to encompass the physical reality of space. We are left with a final question. Is the geometry of Giza a statistical anomaly of ancient engineering, or a deliberate encoding of universal natural law? Purely mathematical dismissals fail to account for the undeniably consistent geometric recurrences we actually observe in the physical universe. Conversely, literal interpretations claiming pi equals phi mathematically will always fail the rigorous standards of number theory. The Great Pyramid remains a singular historical touchstone, the ultimate monument to the tension between the absolute laws of formal mathematics and the physical realities of the universe.